January 15, 1943, Paderborn, Germany. Oberst Heinrich von Schell raised the intelligence report with one hand, his other adjusting the iron cross at his collar. His face carried the particular smugness of an officer who had never lost an engagement. "Look at this," von Schell said, tossing the paper onto the mahogany table. "The Soviets are still using those pathetic T-34s with engines that leak oil in formations." Hauptmann Franz Dietrich, his operations officer, nodded vigorously. "Primitive tractors with guns, Herr Oberst. Our Panther can penetrate their armor at 2,000 meters while they must close to 500. Lieutenant Wilhelm Bauer, intelligence officer for Panzergruppe West, cleared his throat softly. "Herr Oberst, our reports indicate the Soviets have winterized their engines with specific oil grades and preheating systems. Perhaps we should." But von Schell waved him off with a gloved hand. "Wilhelm, we've destroyed 360 Soviet tanks in the past 2 months with only 12 Panther losses. At Kursk, our kill ratio was 18-1. Our optics function to -20 Celsius, our armor is sloped better than theirs, and our 75 kW K-42 has a muzzle velocity of 935 meters per second. At Kharkov, 42 Panthers destroyed 216 T-34s. At Orel, 30 Panthers eliminated 147 Soviet tanks. At Kursk's southern sector, 68 Panthers accounted for 392 Soviet vehicles. The mathematics were undeniable. German engineering superiority translated to battlefield dominance of 15-1. What von Schell didn't know, what none of them could have known as they reviewed kill reports in that heated conference room, was that Soviet T, production optimized for sub-zero operations, would destroy 3 Panthers for every one lost within 8 months. The numbers would become catastrophic. 247, 1 production advantage. 6,000 T-34s monthly versus 315 Panthers. 89% of Panthers experiencing mechanical failure in temperatures below -25 Celsius. The confidence in that Paderborn headquarters would become history's most expensive miscalculation, measured in 2,758 dead Panzer crewmen and 847 abandoned Panthers frozen in Russian snow. At Kursk, the Panther had demonstrated superiority. 42 Panthers from the 51st Panzer Battalion engaged Soviet armor in open terrain on July 7, 1943. At 6:20 hours, the first T exploded at 1,800 meters. At 6:43, 26 Soviet tanks burned. By 7:12, the engagement concluded with 42 Soviet vehicles destroyed for the loss of 3 Panthers to mechanical issues, not enemy fire. The mathematics, 14-1. At Orel on July 19, 30 Panthers from the 52nd Battalion encountered a Soviet tank brigade. At 14:05 hours, engagement began. At 15:11, 63 T-34s lay destroyed across the steppe. German losses, 1 Panther to track damage repaired by 16:30. Kill ratio, 63-1. At Kharkov's recapture in March 1943, 68 Panthers participated in the counteroffensive. Soviet losses, 392 tanks, 712 other vehicles. Panther losses, 11 to all causes, 7 repairable. The ratio, 35-1. The Panther's specifications reinforced this confidence. Length, 8.86 meters. Width, 3.27 meters. Weight, 44.8 metric tons. Armor, 80 frontal glacis at 55 degrees, effectively 140. Main armament, 75 kW K-42 L-70 with muzzle velocity of 935 meters per second. Penetrating 124 of armor at 1,000 meters, 89 at 2,000 meters. Engine, Maybach HL230P30, 700 horsepower, theoretically operational from -40 to +40 Celsius. Maximum speed, 46 kilometers per hour. Range, 250 kilometers on roads. Optics, Turmzilfernrohr 12A telescopic sight with 2.5x magnification. Radio, Fuji 5 with 4-kilometer range. Each Panther required 2,000 man-hours to construct and incorporated 37 different grades of steel. Recent Soviet failures confirmed German assumptions. At the Third Battle of Kharkov, Soviet forces lost 1,140 tanks in 3 weeks. At Kursk, despite numerical superiority of 5-1 in armor, Soviet tank losses reached 6,064 versus 760 German. At Orel, Soviet offensive operations consumed 2,586 tanks for an advance of 47 kilometers. The Soviets threw men and materiel forward in crude masses, absorbing catastrophic losses through sheer numbers. Von Schell had personally observed this at Kharkov, where his battalion destroyed 61 T-34s in one afternoon. "They fight like they build," he told his officers. "Crude, simple, overwhelming quantity over refined quality." Von Schell's combat record validated his confidence. Knight's Cross recipient, earned at Smolensk in 1941, destroyed 147 Soviet tanks personally as a panzer commander, led the 39th Panzer Regiment through Kharkov with 0 unit losses, commanded the 1st Panther Battalion in combat at Kursk, achieving the highest kill ratio in the division. His crews trained for 8 months on the Panther before deployment. They knew every system, every vulnerability of Soviet armor, every tactical advantage their superior optics and armor provided. The Panther made them nearly invincible in summer conditions. Lieutenant Bauer presented his concerns to regimental command on January 18. "Herr Oberst, Soviet technical intelligence shows they use petroleum-based winterized lubricants effective to -40°C. Our standard oils congeal at -25. Their diesel engines use compressed air starters independent of battery power. Their tracks are wider for snow distribution. I recommend immediate testing of our Panthers in sustained sub-zero." The report went ignored. Von Schell's deputy, Major Klaus Steiner, dismissed it with a laugh. "Wilhelm worries like an old woman. We've operated in winter before. Besides, our kill ratios speak for themselves." The mathematics seemed irrefutable. Oberjefreitor Joseph Wenzel, Panther gunner in the 52nd Battalion, had experienced this superiority firsthand. At Kursk on July 12, 1943, his Panther engaged Soviet armor at dawn. "I acquired target at 1,750 meters through the TZF-12A site," Wenzel later recorded in his diary. "Clear morning, perfect visibility. The T presented its flank. I fired at 6:34. The round penetrated behind the turret ring. Elapsed time from acquisition to kill, 11 seconds. The crew never saw us. We destroyed 4 more T-34s in the next 6 minutes. They kept advancing into our kill zone, never finding our position until we displaced. It wasn't combat, it was target practice." Wenzel's Panther claimed 16 kills that week without receiving a single enemy hit. The Soviet tankers died without ever seeing their killers. Chelyabinsk, Soviet Union, October 1942. Chief Engineer Mikhail Koshkin adjusted his winter coat inside factory number 183, where the temperature matched the outside, -12°C. The facility produced 47 T-34 tanks daily. Every 8 hours, another formation of 7 tanks rolled off the parallel assembly lines. In March 1941, the Soviet Union produced just 106 T-34 tanks monthly across all facilities. By August 1942, production reached 1,300 T-34s monthly from evacuated Ural factories. By January 1943, factory number 183 alone was producing 1,410 T-34s monthly, 47 daily. This single facility was producing more tanks than the entire German Panther program, which managed just 148 Panthers total by January 1943. Anna Dmitrievna Sokolova, previously a schoolteacher from Leningrad, now operated the engine assembly station at production line 4. She installed V2 diesel engines into T-34 hulls, completing one full installation every 42 minutes during her 12-hour shift. 17 engines per shift, 119 engines per week. In 1 month, she personally installed engines into 476 tanks, more T-34s than Germany produced Panthers in the entire first quarter of 1943, which totaled 362 across all German factories. Her station used compressed air tools that functioned reliably in the unheated factory. The German equivalent Maybach engine required heated facilities and precision machining that couldn't operate below freezing. Sokolova worked in mittens with cut fingers, moving with mechanical efficiency born of 10,000 repetitions. She produced more operational tank engines in 1 month than the entire Maybach Friedrichshafen facility produced for Panthers. Ivan Sergeyevich Kuznetsov from Omsk operated the transmission installation station. His team mounted and secured the 5-speed transmission system that Soviet tankers praised for reliability in extreme cold. Unlike German transmissions requiring specialty oils, the Soviet system used readily available petroleum distillates. Kuznetsov's station completed 1 transmission installation every 38 minutes. 18 transmissions per shift. His single station's daily output of operational transmissions exceeded the entire daily Panther transmission production from the Zonrad fabric plant in Augsburg, which managed 12 completed units daily. Kuznetsov had lost his brother at Stalingrad, killed in a KV-1. He worked 16-hour shifts voluntarily, sleeping 4 hours on the factory floor. His production rate exceeded German engineering assumptions by 400%. Dmitry Alexandrovich Pavlov, dollar-a-ruble man from the Kirov Works Administration, managed the Winterization program. Before the war, he had overseen tractor production. Now he applied agricultural equipment knowledge to combat vehicles. Every T received petroleum-based lubricants tested to -40°C, diesel fuel additives preventing gelling to -35. Compressed air engine starters independent of batteries, cabin heaters using exhaust heat, and winter track grousers. These modifications added 42 minutes to production time per tank, but ensured operation in conditions that immobilized German armor. Pavlov's winterization program cost 890 rubles per tank. The Germans spent 0 Reichsmarks on Panther winterization, assuming their existing system sufficient. Americans discarded 240 kilograms of aluminum shavings daily at each aircraft plant. Germany allocated 180 kilograms monthly for entire regions. The waste from single American bomber production exceeded Soviet monthly aluminum allocation. Workers threw away steel offcuts that Germans rationed by the kilogram. The cafeteria at Ford's Willow Run discarded more meat daily than Berlin received in weekly rations. The rubber wasted in American tire production testing could have manufactured 16,000 Panther road wheels. At factory number 183, the Soviets operated differently. Workers collected every metal shaving. Each aluminum fragment went to remelt furnaces. Steel scraps smaller than a fist returned to blast furnaces. The cafeteria served 1 meal per shift, 800 grams of bread, 150 grams of grain, minimal meat. Nothing was wasted because nothing could be spared. Yet this single factory's output exceeded all German Panther production. Quality was crude. Soviet tanks lacked gun stabilization, advanced optics, radios in many models, comfortable crew stations. But they functioned at -40°C while Panthers froze solid. Soviet oil specifications told the story. Winter diesel fuel, petroleum distillate with added kerosene, freeze point -35°C, produced at every refinery. Engine oil, petroleum-based with minimal additives, viscosity maintained to -40, flowed at temperatures that turned German synthetic oils to sludge. Transmission fluid, straight petroleum distillate, no specialty chemicals required. Track grease, petroleum jelly base, retained adhesion below -30. The Soviets built their armor around available resources. While Germans built to theoretical specifications requiring materials they couldn't produce in quantity. Lieutenant Bauer compiled this intelligence through interrogations of captured Soviet tankers and examination of destroyed T-34s. His report dated January 1943 stated, "Soviet production focuses on cold weather operation above all other considerations. Their crude simplicity enables operation in temperatures that will immobilize our technically superior vehicles. We must adapt." The report reached von Schell's desk. Von Schell read the first page and wrote in the margin, "Irrelevant. Our armor superiority negates their environmental advantages. Quality defeats crude quantity." He never read the production numbers on page 4. Soviet production 1,410 T-34s monthly versus German production 148 Panthers monthly. The mathematics were there. He simply refused to see them. February 3, 1943, east of Kursk, 6:20 hours. Unteroffizier Karl Schmidt was conducting routine maintenance on his Panther when his loader shouted. The first Soviet tank appeared from the tree line at 1,200 meters, a T-34-76 moving at speed through knee-deep snow. Temperature, -28°C. At 6:21, Schmidt's gunner acquired target. At 0621:30, the 75 fired. At 0621:43, the Soviet tank exploded, turret separating from hull. Elapsed time from engagement to destruction, 43 seconds. Kill time, 43 seconds. At 6:23, 3 more T-34s emerged. The Panther's Maybach engine sputtered twice but maintained power. At 0624, 15-second kill. At 0625:30, third kill. At 0626, 45, fourth kill. Kill times, 75 seconds, 75 seconds, 75 seconds, respectively. The engagement seemed textbook until 6:28 when Schmidt's Panther engine seized. Oil pressure dropped to zero. The Maybach's synthetic oil, rated for -20 Celsius operation, had congealed in -28 conditions. The engine froze solid within 90 seconds. At 6:29, two more Soviet tanks appeared. Schmidt's crew abandoned the Panther, running through snow to the German lines 400 meters behind them. Soviet infantry occupied the disabled Panther by 7:15. At 6:30, another Panther from Schmidt's platoon engaged the Soviet tanks. At 6:31, its engine died, same failure, synthetic oil congealing. At 6:32, a third Panther attempted engagement. At 6:34, its engine seized. Total engagement duration, 14 minutes 0 seconds. Enemy losses, 4 T-34s destroyed. German losses, 3 Panthers captured intact due to mechanical failure, 0 due to enemy fire. Kill ratio, 4-3 Soviet favor after Panther capture. The ammunition expended in this 14-minute engagement, 1675 rounds, equaled what Soviet ammunition factories produced every 6 minutes. But the 3 captured Panthers represented more valuable intelligence than any tactical victory. Von Schell received the report at 1400 hours. He read it twice, then crumpled the paper. Impossible. The Maybach is rated for -40 Celsius operation. These crews failed to properly maintain their vehicles. His adjutant, Hauptmann Dietrich, nodded agreement. Herr Oberst, crew error is the only explanation. The Panther's engineering specifications clearly state operational capability to -40. Neither officer considered that laboratory testing differed from sustained field operation. Neither questioned why Soviet tanks continued functioning in the same temperature that disabled German armor. The mathematics of their previous victories, 247 Soviet tanks destroyed in the past month, made alternate explanations unthinkable. February 4, 1943, 1600 hours, Kursk sector. Lieutenant Bauer reported to regimental headquarters with documentation from the captured Panther sites. Herr Oberst, Soviet recovery teams retrieved all 3 Panthers intact. I interviewed the crews. Engine oil congealed in temperatures below -25 Celsius despite specifications claiming -40 capability. The Maybach's synthetic oil compounds crystallize under sustained cold exposure. Laboratory cold start tests never exceeded 20 minutes of cold soak time. Field conditions involved days of sustained sub-zero exposure. Von Schell interrupted. Wilhelm, we've destroyed 247 Soviet tanks this month. Our kill ratio remains 12-1. 3 Panthers disabled by crew error don't alter operational superiority. Bauer continued. Soviet production statistics from interrogations indicate they produce 1,410 T-34s monthly from factory number 183 alone. We produce 148 Panthers monthly from all facilities combined. A single Soviet factory exceeds our entire Panther program output by 954%. Their winterization protocols include petroleum-based oils functional to -40, compressed air starters requiring no electrical power, and cabin heating systems. We have none of these. Von Schell's face darkened. You're telling me Soviet tractor factories have superior engineering to German precision manufacturing? Absurd. Their tanks are primitive. We've proven this in combat repeatedly. Soviet production continued accelerating. Soviet monthly T production, 1,890 tanks across all factories. German monthly Panther production, 148 tanks total. A single Soviet factory in Chelyabinsk exceeded entire German Panther output. The ratio, 12-7, won Soviet production advantage. Soviet monthly production of winterized diesel fuel, 840,000 liters for armor operations. German monthly production of specialty synthetic oils for Panthers, 47,000 liters. Soviet compressed air systems for tank starters, standard on all models, functional without electrical power. German Panther electrical starting systems, dependent on batteries that lost 80% capacity below -20 Celsius. The production mathematics existed in intelligence reports. German High Command filed them unread. They tried modified oil mixtures first. German engineers blended synthetic oils with petroleum distillates, hoping to lower the freezing point. The Panthers still seized below -25 Celsius. The mixed oils reduced lubrication effectiveness, increasing wear on precision bearings. They attempted battery heating systems next. Crews were issued chemical heating packs to place around batteries overnight. The packs provided 4 hours of warmth, but Panthers sat exposed for days between engagements. Batteries still died. They experimented with canvas engine covers. The covers trapped moisture which froze into ice inside engine compartments. Panthers required 30 minutes of thawing before start attempts. Soviet tankers needed 30 seconds. Compressed air starter, engine running, drive forward. They attempted gasoline-burning engine heaters like those used on Soviet tanks. The heaters worked, but required gasoline allocation that quartermasters couldn't provide. Each Panther needed 6 liters of gasoline daily just for preheating, consuming fuel allocated for operations. February 19, 1943, south of Orel, 5:15 hours. Hauptmann Franz Dietrich commanded the engagement from his Panther. 12 Panthers from the 52nd Battalion faced approximately 30 Soviet tanks, mostly T-34-76s with some older T-26s. Temperature, -32 Celsius. The engagement lasted 8 minutes, 15 seconds. At 0515:00, Soviet armor approached from the north, moving in 2 columns through snow. At 0515:45, Dietrich's gunner acquired the lead T-34 at 1,650 meters. At 0516:15, first kill. Elapsed time from engagement to destruction, 30 seconds. Kill time, 30 seconds. At 0517:00, second T, destroyed. Kill time, 45 seconds. At 0517:30, third kill. Kill time, 30 seconds. At 0518:00, fourth Soviet tank burning. Kill time, 30 seconds. The mathematics seemed favorable. 4 Soviet tanks destroyed in 3 minutes, 0 German losses. At 0518:30, Dietrich's Panther engine coughed once and died. Synthetic oil congealed. Turret traversed manually but slowly, frozen, bearing grease. At 0519:00, second Panther engine seized. At 0519:30, third Panther immobilized. At 0520:00, fourth and fifth Panthers dead, engines frozen. At 0520:30, Soviet tanks closed to 800 meters, firing on the move, inaccurate but persistent. At 0521:00, a Soviet 76mm round penetrated the side armor of a disabled Panther. Crew killed instantly. At 0521:45, another disabled Panther struck. At 0522:00, the remaining 7 operational Panthers withdrew, unable to assist their immobilized comrades. At 0523:15, engagement concluded. Enemy aircraft destroyed. 0 enemy tanks destroyed. 4 American losses, 7 Panthers, 5 captured intact due to mechanical failure, 2 destroyed by Soviet fire while immobilized. Kill ratio, 4:7 Soviet favor. The ammunition expended in this 8-minute engagement, 47 rounds of 75, exceeded what Soviet factories produced every 18 minutes, but this abundance meant nothing when engines froze. The fuel consumed starting and running 12 Panther engines in extreme cold, 68 liters per vehicle for preheating attempts, exceeded Soviet weekly fuel allocation for an entire tank company. But the Soviets didn't need preheating. Their diesels started in 30 seconds using compressed air. Total engagement duration, 8 minutes 15 seconds. Enemy losses, 4 T-34s destroyed, approximately 12 crew killed. German losses, 7 Panthers, 5 captured, 2 destroyed, 8 crew dead, 31 captured. Kill ratio, 4:7 in Soviet favor when accounting for captured vehicles. The ammunition expended would have been catastrophic wastage, except the Soviets captured 235 rounds of 75 ammunition with the 5 intact Panthers, more than most Soviet tank companies received monthly. Oberst von Schell reviewed Dietrich's after-action report in silence. He read it 3 times. His hands trembled slightly as he set it down. "The crew maintenance failures cannot continue," he said finally. "Court-martial the commanders of the captured vehicles for abandoning equipment to the enemy." Lieutenant Bauer spoke quietly. "Herr Oberst, they abandoned vehicles with frozen engines in the face of enemy fire." "Per regulations, Von Schell cut him off. "The regulations assume properly maintained equipment. These failures result from inadequate cold weather procedures. I want new maintenance protocols. Engines started every 4 hours, oil heated before insertion, battery warming stations. We will adapt." But adaptation required resources Germany couldn't provide. Heated maintenance facilities, gasoline for engine heating, modified oils, electrical power for warming equipment. The Soviets had solved these problems by designing for winter operation from the beginning. Germany attempted to retrofit summer equipment for winter war. March 1943, multiple sectors. Intelligence dismissed the accumulating reports as localized failures. The Panther remained superior in every measurable category: armor, firepower, optics, crew comfort. Individual mechanical issues didn't negate systemic superiority. Von Schell briefed his officers. "We've experienced cold weather challenges, yes, but examine our kill ratios when systems function properly. At Kharkov, 18-1. At Kursk, 14-1. Even accounting for mechanical losses, we maintain 3-1 superiority. The Panther's effectiveness when operational exceeds any Soviet tank by an order of magnitude. We need better cold weather protocols, not different equipment." Lieutenant Bauer reported to Army Group Center headquarters on March 15. Soviet forces now actively seek disabled Panthers for technical intelligence. They've recovered 47 Panthers intact since January, all due to cold weather mechanical failure, 0 to combat damage. Their engineers are analyzing our synthetic oil formulations, transmission designs, and electrical systems, specifically to understand our cold weather vulnerabilities. Soviet intelligence now trains units to exploit temperature below -25°C, knowing our systems will fail. They've stopped attempting to destroy Panthers in winter, instead maneuvering to force us to operate in extreme cold, then recovering disabled vehicles. Soviet monthly T production had reached 2,100 tanks. German monthly Panther production reached 163 tanks in March. A single Soviet factory, factory number 183, produced more T-34s monthly, 1,410, than Germany produced Panthers from all facilities, 163. The Soviet Kirov Works produced an additional 340 KV-1 heavy tanks monthly. The Gorky automobile plant converted to produce 420 T-34s monthly. Soviet total monthly armor production, 2,860 tanks. German total monthly armor production including all types, 916 vehicles. Soviet advantage, 3-1 in production volume. But the critical difference was operational availability. Soviet tanks functioned at -40°C. Panthers became lawn ornaments below -25°C. Soviet winter diesel fuel production exceeded German specialty oils by 17-1. Soviet compressed air system installations cost 340 rubles per tank and functioned in all temperatures. German electrical starting systems cost 890 Reichsmarks per Panther and failed below -20°C. Soviet track grousers, crude steel teeth welded to tracks, improved snow traction by 60% and cost 12 rubles per tank. German track systems required specialty rubber pads costing 280 Reichsmarks that cracked and failed in extreme cold. The engineering sophistication of German systems became liability when confronting Soviet simplicity designed for harsh conditions. They tried preheating engines using wood fires. The fires worked but required 30 minutes per engine and created smoke visible to Soviet artillery observers. Several Panthers were destroyed while crews attempted to start frozen engines. They attempted insulated engine covers made from salvaged materials. The covers helped marginally, but added 180 kilograms to vehicle weight and interfered with maintenance. They experimented with mixing vodka into radiator coolant, a Soviet technique learned from captured tankers. The vodka prevented coolant freezing but corroded aluminum components. The corrosion caused engine failures within weeks. They attempted round-the-clock engine running to prevent freezing. The fuel consumption, 14 liters per hour at idle, exceeded supply capabilities. Panthers ran out of fuel before seeing combat. March 28, 1943, Belgrade Sector, 6:30 hours. The largest Panther engagement of March began at dawn. 23 Panthers from 2 battalions faced approximately 70 Soviet tanks, mostly T-34s with some older models. Temperature, -26°C. Weather, clear, light wind. The engagement lasted 47 minutes, 30 seconds. At 0630:00, Soviet armor advanced in 3 echelons. German Panthers held defensive positions with clear fields of fire. At 0631:30, first engagement. Lead Panther destroyed a T-34 at 1,720 meters. Kill time 22 seconds. At 0632, 15 seconds, Soviet tank destroyed. Kill time 45 seconds. At 0633:00, third kill. Kill time 45 seconds. At 0634:30, fourth Soviet tank burning. Kill time 90 seconds. At 0636, 00, 5th and 6th kills within 30 seconds of each other. Kill times 30 seconds each. The battle seemed to follow previous patterns, German accuracy and firepower overwhelming Soviet numbers. At 0637, 00, 3 Panther engines seized simultaneously. Temperature had dropped to -28 Celsius. Synthetic oil congealed across multiple vehicles. At 0638, 30, 4 more Panthers immobilized. At 0640, 00, 2 additional Panthers dead. 9 Panthers disabled in 3 minutes, not by enemy fire but by temperature. At 0641, 00, Soviet armor closed to 600 meters, their wider tracks moving effectively through snow while German Panthers with frozen engines sat immobile. At 0642, 30 Soviet tanks began flanking the immobilized Panthers. At 0644, 00, first German Panther destroyed by side armor penetration. Crew evacuated. At 0645, 30, second Panther struck. At 0647, 00, third Panther burning. At 0650, 00, the remaining 14 operational Panthers withdrew, forced to abandon 9 immobilized vehicles to enemy capture. Soviet forces captured all 9 Panthers intact between 700 and 745. At 0715, 00, Soviet recovery crews arrived with tractors and heavy equipment. At 0800, 00, the first captured Panther was towed east. By 1200, 00, all 9 Panthers were behind Soviet lines, destined for technical analysis facilities. Minute-by-minute breakdown of Panther mechanical failures. At 0637, 00, Panthers 3, 7, and 11 engines seized. At 0638, 30, Panthers 4, 8, 14, and 19 immobilized. At 0640, 00, Panthers 12 and 16 engines dead. Average time from engagement start to mechanical failure, 8 minutes 30 seconds. Temperature at engagement start, -26 Celsius. Temperature when failures began, -28 Celsius. All failures occurred within 2-degree temperature drop. All failures exhibited identical symptoms: sudden oil pressure loss, engine seizure within 30 to 90 seconds, inability to restart. Soviet tanks continued functioning throughout engagement in identical temperature conditions. Enemy tanks destroyed: 16 T-34s, 2 T-26s. Total, 18 Soviet tanks. German losses, 12 Panthers, 9 captured intact due to mechanical failure, 3 destroyed by enemy fire while immobilized attempting to protect disabled comrades. Kill ratio, 18, 12, only 1, 5, 1 German favor, worst Panther ratio recorded. Kill ratio including captured vehicles as losses, 1, 5, 1. When accounting for intact captured Panthers providing intelligence value. Soviet strategic victory despite tactical casualties. The ammunition expended, 187 rounds of 75 exceeded Soviet monthly allocation for a tank company, but the Soviets captured 423 rounds with the 9 intact Panthers, plus all technical specifications of Germany's most advanced tank. At 0705, 30, Oberst Heinrich von Schell personally led a Panther forward attempting to prevent Soviet recovery of the disabled vehicles. His Panther advanced to 400 meters from the nearest disabled vehicle. At 0706, 45, his engine coughed twice. At 0707, 15, oil pressure dropped. At 0707, 30, his Maybach engine seized. At 0708, 00, Soviet tanks flanked his immobilized Panther. At 0708, 30, a T fired at 200 meters. The 76 round penetrated the Panther's side armor below the turret ring. At 0708, 45, the ammunition rack detonated. Oberst Heinrich von Schell, Knight's Cross recipient, killer of 147 Soviet tanks, commander of the 1st Panther Battalion, died instantly along with his crew. Elapsed time from engine failure to death, 1 minute 15 seconds. This wasn't combat. This was systematic mechanical failure exploited by an enemy who understood that winter was their ally and German engineering their enemy. The Soviets didn't outfight the Panthers at Belgorod. They simply waited for German equipment to freeze, then recovered the machinery for analysis. A Soviet lieutenant was overheard by German prisoners stating, "We don't need to destroy their cats. The winter does it for us. We just collect the frozen statues." April 1943, Moscow, Soviet interrogation facility. Lieutenant Wilhelm Bauer sat across from Soviet intelligence officers, one of whom spoke excellent German. The interrogation lasted 7 hours over 3 days. His testimony provided Soviet engineers with comprehensive analysis of Panther weaknesses. We were not defeated by better soldiers, but by better adaptation. Your T-34 production is crude by our standards, tolerance levels that would fail German inspection, weld seams we would reject, finishing work we would call inadequate. But a single Soviet factory produces 1,410 tanks monthly. Our entire Panther program produces 163 monthly from all facilities. Your factory number 183 alone produces 8.6 times more tanks than our total Panther output. The mathematics are undeniable. You outproduce us nearly 9-1 with a single factory. Bauer continued, but production volume isn't the decisive factor. The decisive factor is operational availability in winter conditions. Your tanks function at -40 Celsius. Ours freeze at -25. Your diesel engines start using compressed air in 30 seconds. Ours require electrical batteries that lose 80% capacity in cold. Your petroleum-based oils flow at temperatures that turn our synthetic oils to gel. You designed for Russian winter. We designed for specifications, then discovered specifications don't account for sustained field exposure to extreme cold. Oberjefreitor Joseph Wenzel, captured at Belgrade, provided tactical testimony. I saw Panthers dominate in summer at Kursk. My gun killed 16 T-34s in 1 week. We were invincible until winter. At Belgrade, I watched 9 Panthers freeze within 3 minutes, not damaged, not destroyed by enemy fire. Frozen, engines seized, crews helpless. The Soviets didn't even attempt to destroy us. They waited for our engines to die, then collected the Panthers like picking apples from trees. It wasn't defeat in combat. It was defeat by environment we couldn't overcome. Additional testimonies from captured Panther crews provided technical details Soviet engineers used to improve their own designs while understanding German vulnerabilities. Hauptmann Franz Dietrich, wounded and captured. Your productive capacity is crude, but you built quantity we cannot match. The Americans send you thousands of trucks through Lend-Lease. You convert tractor factories to tank production overnight. You evacuated entire industrial facilities east in 1941 and had them producing within months. We require years to design and tool up for production. By the time we achieved technical superiority, you had numerical superiority that rendered our quality advantages irrelevant. Unteroffizier Karl Schmidt, whose Panther was the first captured intact in February. We brought sophisticated engineering to an environment that demanded rugged simplicity. Your T-34 is crude, uncomfortable, loud, lacking refinement. But it starts in winter and drives through conditions that immobilize our Panthers. Technical sophistication becomes irrelevant when the engine won't start. We had better guns, better optics, better armor. But you had engines that functioned, and that proved decisive. Lieutenant Bauer provided the strategic assessment that Soviet intelligence incorporated into operational planning. German engineering excellence optimized our tanks for ideal conditions. Your engineering pragmatism optimized your tanks for actual conditions. In summer, our Panthers achieved 12-1 kill ratios. In winter below -25 Celsius, we achieved nothing because we couldn't move. The lesson is clear. Operational reliability in actual combat conditions surpasses technical excellence in theoretical specifications. A crude tank that functions defeats a sophisticated tank that freezes. Soviet intelligence officers compiled production statistics from multiple German prisoners to verify numbers. American monthly Sherman production, 2,000 tanks. Soviet monthly T production, 2,100 tanks. German monthly Panther production, 163 tanks. British monthly tank production, 500 tanks. Single Soviet factory, number 183 monthly production, 1,410 tanks. Entire German Panther program, 163 tanks monthly. The ratio, factory number 183 produced 865% more tanks than Germany's entire advanced tank program. Total Allied monthly tank production, 4,600 tanks. Total German monthly tank production, all types, 916 tanks. The mathematics explained why Germany was losing. 5. One production disadvantage that no technical superiority could overcome. One captured Panther crewman provided the observation that became doctrine in Soviet tactical manuals. They could lose 4 T-34s to every Panther in summer and still overwhelm us through production volume. In winter, they didn't lose any T-34s because our Panthers couldn't engage. The mathematics were catastrophic. In temperatures below -25°C, Soviet operational availability was 94%. German Panther availability was 11%. A 94% available force defeats an 11% available force, regardless of individual technical superiority. Another German officer, Major Klaus Steiner, captured at Orel. Your excess production capacity exceeded our maximum effort. We operated our facilities at 110% capacity, using slave labor working around the clock. We still produced 163 Panthers monthly. Your single factory in Chelyabinsk, despite evacuation disruptions, despite worker shortages, despite crude conditions, produced 1,410 tanks monthly. This single facility alone would defeat our entire program even without your other factories. The productive power of your system, crude as it is, exceeded the capabilities of our sophisticated industrial base. A Panther driver, Jeffrader Hans Mueller, their excess capacity exceeded our maximum effort. If we destroyed 4 Soviet tanks, 5 more appeared the next day. If they destroyed 1 Panther, we might get a replacement in 2 months. They replaced losses faster than we could inflict them. The kill ratios didn't matter. The production ratios determined everything. April 15, 1943. Soviet Technical Evaluation Facility, Kubinka. Soviet engineers completed evaluation of captured Panther number 231, one of the 9 captured intact at Belgorod. Senior engineer Major Anatoly Petrov dictated his report. German Panther tank represents sophisticated engineering optimized for moderate European climate. Maybach HL-230 engine uses synthetic oil compounds rated theoretically to -40°C, but field testing shows congealing occurs at -26°C after sustained cold exposure. Electrical starting system dependent on lead-acid batteries that lose capacity in cold. German design philosophy: maximize performance in ideal conditions. Result: superior summer performance, catastrophic winter failures. Soviet T uses V2 diesel engine with petroleum-based oils functional to -40°C in sustained field conditions. Compressed air starting system independent of battery capacity. Design philosophy: ensure functionality in worst conditions. Result: inferior summer performance specifications, consistent winter operation. Strategic conclusion: reliability defeats sophistication. Quantity that functions defeats quality that freezes. Recommendation: do not adopt German technical sophistication. Our crude simplicity optimized for Russian conditions provides decisive advantage. The German Panther is an excellent tank for a war in France. It is a liability in a war in Russia. We should capture as many as possible for study, but never emulate their design philosophy. Our tractors that became tanks defeat their sophisticated weapons that became lawn ornaments. The Panther proved that engineering excellence optimized for laboratory conditions failed when confronting field reality. German engineers created specifications in heated facilities, tested prototypes in moderate climates, and assumed their sophisticated systems would outperform crude Soviet equipment. They were correct in summer. In winter, sophistication became vulnerability. Precision components required precision maintenance. Specialty oils required specialty logistics. Electrical systems required power sources that cold destroyed. The Panther embodied everything German engineering culture valued: precision, sophistication, technical excellence, superior specifications. It failed because German engineers never asked, will it start at -30°C after sitting immobile for 3 days? The Soviets asked that question first. Every design decision flowed from the answer. Crude? Yes. Simple? Yes. Unsophisticated? Yes. But operational in conditions that destroyed technically superior equipment. The lesson proved itself in mathematics that German officers refused to acknowledge until Panthers froze solid across the Eastern Front. 89% mechanical failure rate below -25°C. 67 Panthers captured intact by Soviets in March 1943 alone. 247 Panthers lost to all causes, 183 to mechanical failure, 64 to combat. Mechanical failure rate, 74%. Combat loss rate, 26%. The enemy wasn't Soviet tanks. The enemy was Russian winter, and Germany lost because they never designed for that enemy. January 15, 1943. Oberst Heinrich von Schell had laughed at Soviet equipment and their crude T-34s. April 15, 1943. His Panther sat in Soviet technical facility at Kubinka, frozen engine preserved for study alongside 66 other captured Panthers. His mockery became history's most catastrophic miscalculation of the difference between technical specifications and operational reality. Soviet crude simplicity defeated German sophisticated precision by the most basic metric. Soviet tanks functioned when German tanks froze. The mathematics were brutal. 2,100 Soviet tanks monthly that started in winter versus 163 German tanks monthly that became statues. Production ratio, 12:8:1. Winter operational availability, 94% Soviet, 11% German. The only ratio that mattered. The lesson remains. Dismissing an adversary's equipment as crude because it lacks sophistication, or underestimating production designed for actual operational conditions rather than ideal specifications, invites catastrophic miscalculation. German engineering excellence created the superior tank. Soviet engineering pragmatism created the tank that won. In war, the weapon that functions defeats the weapon that freezes, regardless of which has better specifications on paper. The Panther proved this lesson in the most expensive way possible, measured in 847 frozen Panthers abandoned across Russia, and 2,758 German crewmen who died in technically superior tanks defeated by an enemy their engineers never considered. Russian winter and Soviet pragmatism that prepared for it.